Hello class, today we're covering how to conduct a chi-squared test. To do that, we'll be in section 11.2, working on number 1. Let me go ahead and read that to you. A poll was conducted to investigate opinions about global warming. The respondents who answered yes when asked if there is solid evidence that the Earth is getting warmer were then asked to select a cause of global warming. The results are given in the accompanying data table. Use a 0.05 significance level to test the claim that the sex of the respondent is independent of the choice for the cause of global warming. Do men and women appear to agree, or is there a substantial difference? So the first thing we want to look at is this table here. Before we fill it in, all it gives us is these 6 numbers. The first thing we want to do is come up with a rows total and column total. As you can see, I added them over here. To find the row total, we're going to add all these numbers in row 1 and we get 546. To get the next row total, add up all the numbers in row 2 and we will get 544. Next, do the same thing for the column totals. Add these 2 numbers in column 1, get 628. Add these 2 numbers in column 2, get 305. Add these 2 numbers in column 3, get 157. And you can either add all 6 of these numbers, or add the row totals, or add the column totals, and you'll get 1090. Now notice I said or in there. Do not add all 3 of those together. Just add one of those 3 options. Now that we have that, we can identify the null and alternative hypothesis. To do hypothesis, again, we have to state the null, which is this h sub 0, and the alternative, which is h sub 1. For the null, we're going to say the sex of the respondent and the choice for the cause of global warming is independent. The alternative would be the sex of the respondent and the choice for the cause of global warming is dependent. These little marks here means just rewrite the same thing above it. Now that we have the hypothesis out of the way, let's move on to the test statistic. And as usual, we need a formula for that. The formula for this test statistic looks very simple. We have chi-squared equals sum of observed minus expected squared all over expected. The O here, the observed, are these numbers that we are given in the table. The expected is given to us by row total times column total over grand total. So let's go ahead and fill some of these in. Chi-squared equals, the first observed value is 327, minus, to get this expected value, we take the row total of 546, multiply it by the column total of 628, and divide it by the grand total. This is what we have right here. And then we square this. Then we divide this entire thing by the expected value again. We got that the exact same way we did up here. Now since it says sum, we're going to have to add that to the next step. The next value is 137 minus, to get expected, it's row total, so 546 times column total of 305 divided by grand total of 1090, and then square that all over that same expected value. Do make sure you watch out for the squares. They're very easy to forget. So plus, repeat that with the 82. So 82 minus 546 times 157 divided by 1090. Square this and divide the entire thing by that same expected value. Plus, the next observed is 301. We're going to subtract that by 544 times 628 all over 1090. And again, square that, divide that by that same expected value, plus 168 minus, to get its expected value, 544 times 305 divided by 1090 squared, and again divide that by that expected value, plus our last observed would be 75 minus 544 times 157 divided by 1090, And again, square that, divide the entire thing by that expected value. Now do notice these expected values are different, so pay attention to those. When you plug this on the calculator, make sure you get the parentheses in the right area, and you may need an extra set of parentheses on these bottoms here. I didn't because of my calculator, but based on your calculator, you may need an extra set of parentheses down here. When you put this in, you should get approximately 4.548. If you're unable to get that, check your parentheses again, and if you still can't get it, make sure you contact me. Next thing we're going to do is find the critical value. To find the critical values, we need our degrees of freedom. This degrees of freedom is a little bit different from what we're used to. It is R minus 1 times C minus 1. R is our number of rows, C is our number of columns. So we have 2 rows here and 3 columns. That will give me 2 minus 1 times 3 minus 1, which would be equal to 2. Our alpha is our level of significance, which would be 0.05. Whenever we look this up in the table, and I'll go ahead and I'll post the table right here, find degrees of freedom 2, alpha equals 0.05. And we should get the critical value to be 5.991. Now that we have our critical value, we can move on to our conclusion. I went ahead and sketched this, and it's a little off the table, or a little off the video here, but you can see the general form of the chi-squared graph. This little shaded area here is our tail. This right here is our critical value. This number is 5.991. Our test statistic is located over here in this clear area, 4.548. Since this is not in the tail, it's not in the rejection area, we will fail to reject H0. If you have any questions about how we came up with the hypothesis test, got our row, column, or grand totals, how we used the test statistics, got the expected values, read the chi-square table, or how we got our conclusion, remember you can message me through course messaging, or you can post a discussion board in Blackboard.